Hello, and welcome back to our Lifehack series. Today, we will talk about fidelity and OpenLabs. OpenLabs is a part of fidelity, and you may have heard before FineOpen with OpenLabs. It is basically the same now in fidelity. And OpenLabs is a tool which gives you the option to interact with the underlying flow solver of fidelity. So you can adapt the flow model, the turbulence model, you can adapt boundary conditions, you can change parameters, you can introduce any additional model you want, and many further things as well. You can find it in the manual in the simulation context, in the part of the optional models. There's a section regarding OpenLabs. And as an example, how it can look like, you can really insert a complete scalar transport equation with a time derivative term, the convection term, diffusion term, and source terms. Now this is already quite advanced, but we prepared a case for you, which is a little simpler and hopefully useful as well, and it will be shown in the following. The case you can see here, it is it's some part of the radial compressor tutorial. Basically now we just focus on the impeller here. We have a simple steady state initialization, and we have another case which is called surge limit in order to detect the surge line. You can see here the mass flow, the inlet-outlet mass flow, starting from a converged solution, and then we changed the mass flow. We basically reduced the mass flow in each step by a certain percentage. The flow solution oscillates, we let it converge and do the next change, and that we repeat in order to see where the surge limit would be, because in the end the oscillations will be significant and the flow solver doesn't converge anymore, as you can see here below. All that procedure is done within OpenLabs without any manual interaction. How is it done? In that case, it's basically right click on the domain and edit labs. Please note, if you have several domains and you want to adapt the flow model in all of the domains, you have to create the labs for each of the domains. So here, right click on edit labs, which opens a new window. On the left side, this could be empty when you start it the first time. Simply click here on the analysis mode. On the left side, you have all the information the flow solver is using internally. So starting with the constants, you have the constants, for example, of the turbulence model, which you could also modify. In that case, lift, drag direction, rotation, frequency, and so on. You have the CFD variables. Of course, they are computed, so they are just read-only values. Same as with geometric and numerical values. You have the fluid properties and the different equations you could adapt. The boundary conditions you could adapt, and this is also what we will do here. We have the internal boundary condition outlet, and we will change the mass flow. And then on the right side, that's our code. So not the one the flow solver uses anyway, but the code we basically modified in order to make the simulation as I described before. We have a periodicity, in that case 15 blades. We have a starting outlet mass of 2 kg per second. We have a reduction factor, so basically we reduce by 5% each time we change the mass flow. We have a minimum iteration step of 1000, so the mass flow is changed at each 1000 steps. We have an interval of 800 iterations before we consider if the mass flow is converged or not. And we have a tolerance of the mass flow, let's say of 5% in that case, which then can be used as a limit if you consider the simulation converged or not. 5% of course is a big value. This is just an example. Then we have a function which returns the internal iteration number basically of each of the design changes. And we have a few functions here in order to compute the average mass flow. They look a little bit more complicated maybe than in the end they are, because we don't have the history of the mass flow in that case. So the average mass flow error is computed after 800 iterations of each design change. And then basically it's the sum of the mass flow errors within that range divided by the amount of that sum. And otherwise it's simply 0. You can see also here, export history to file, that this information is written to a file, an ASCII file, which you can simply plot with GNU-plot, for example, and also have a closer look on the different values. Then we have a constant called stop_sim, which basically returns 1 if that 5% mass flow error is reached. Mass aim is the mass flow in each design iteration we want to aim for, so every time 5% less than before. Equations in that case is empty, but we modify and customize a boundary condition. The mass flow in the outlet should have the value of mass aim, which is here defined as a constant. Further entries are empty, and down here we have the global quantities of the mass flow, which is going into the domain and out of the domain, and we compute the mass flow error by hand, because if you have a closer look on the left side, we don't have that information as a variable. At least it's not accessible for us. All what is written here can be imported as an external file, and also of course you can export that. Then you need to activate the checkbox Enable Labs and Validate Lab. That usually takes a second, but in that case the compilation is okay. If it is not okay, it is shown at which place an error appeared. This is part of the graphical user interface. However, in the computation folder of that case, there's also an OpenLabs folder, which includes a log file with more detailed information in case something went wrong. And then when you're done with that and everything worked well, you simply start the simulation as usual. That case here was done on Linux, as you can see it. However, you can also do that on Windows. In both cases, you need to have the proper compilers, but that information you can find in the manual. Otherwise, please write to our support team. And as a further note, in the manual of FineOpen, there were a few demo and tutorial cases with OpenLabs. They are not yet transferred to Fidelity, so if you need further inspiration, please have a look in the legacy documentation of FineOpen. So, that was it for today. Thank you for watching, and if you have any questions regarding OpenLabs or anything else, please let us know, write to our support team, and otherwise, just see you next time. Thank you.